as you've probably already been told. NFTs are responsible for massive amounts of pollution, resulting in turtles getting stuck in plastic, oil leaks in the ocean, deforestation, fracking, and other consequences that can only be marked in status accurately as catastrophic. Or at least this is the argument propagated popularly on the internet, seemingly originating from Digiconomist's article. Now, we can see on the screen exactly how it is, how they are calculating this figure, and exactly where they're getting their data from to plug into this to conclude that NFTs are really detrimental to the environment. Things of note, just in the language, the calculation convert to US dollars. Sounds like there might actually be a conversion fee. It doesn't say that the profits were taken in US dollars or the amounts in US dollars. It says converted to US dollars. So I'm not quite sure if that means that there's some sort of percent in there for exchange rates and stuff like that, and I don't know how that would affect it. I'm going to assume not, but the language is a little bit strange. It's then estimated what percent of the mining revenues are spent on electricity. So this would be different geographically as to what percent would be spent on mining and electricity. Like this says later on in the article, the amount of power used for mining isn't necessarily all on mining. Some of it will be on cooling and stuff like that. Although associated activities really should be included as well. We should be wanting to be responsible for that as we are using the system. And it's divided by the average price per kilowatt hour. Now, as someone that used to be an area sales manager for a company that would sell industrial air compressors, these machines' power was measured in kilowatts. Now, I know from speaking to people in the UK that even just across county lines, or even in the same county, can mean different prices for electricity. Depending on the industry, depending on whatever specific deal they have in place, the amount that they would use, the amount that it would cost per kilowatt is not going to be the same for anyone. So, to take an estimate of this figure is really not very representational of the true scenario. Even when calculating Bitcoin's own energy consumption, it basically admits that it knows nothing. So this article then goes on to compare it against electricity for usage for countries. Now, for me personally, these two aren't analogous. You can't be comparing them, or you can, but there's not really much point because they're apples and oranges. Why would you expect an entire country to be using the same electricity as something that specifically needs electricity to run? It's almost like you're trying to imply something that isn't necessarily concluded by the premises. That Bitcoin's bad, that these things are inefficient. And yeah, you can make it seem that way when you put it against erroneous facts and figures.
It's all a fugazi. You know what a fugazi is?
No, fugazi. It's fake.
Yeah, fugazi. It's a wazi, it's a woozy, it's a fairy dust. It doesn't exist. It's never landed. It is no matter. It's not on the elemental chart. It's not fucking real.
Right.
All right? Right. Stay with me.
Mm-hmm.
So then they're comparing Ethereum to other payment systems. This is stuff like Visa, and whilst I admit that Ethereum cannot process as many transactions for the energy or the amount of time, it is the case that Ethereum is not just a payment system. Once again, this is apples and oranges, trying to imply something that isn't necessarily the case. It's like the equivalent of me saying my car, which has a radio in, uses more electricity than this radio. So, well, yes, of course it would, because not only is it a radio, but it's also a vehicle with an internal combustion engine, lots of other different functionality that doesn't occur just within a radio. It's not me saying that energy is not a concern with regards to NFTs. Yes, it is, in the same way that everything else is. We should make incremental change to try and improve on these things as soon as possible. But that doesn't mean we should go around slandering what does exist when it's absolutely brand spanking new, especially when there's other existing industries that have been around for a long time and are arguably far, far worse. It's clear to me, if NFTs use less electricity, then they'd probably be less criticised and further utilised by artists, which provides further value for everyone involved. If I were to compare Ethereum to something like the paint industry, we can see that for every tin of paint, as detailed by this study, it's roughly 15 kilograms of CO2 that's released into the atmosphere. Now, according to Digiconomist, NFTs are roughly double that amount, right? So, to me, firstly, that doesn't sound that bad. One NFT is double a tin of paint. Now, if I was an artist and I was painting on the canvas, I'll probably need at least a palette of paints, right? So say I need 5 tins of paint, right? And say that art tins of paint are made the same way as industrial paint. I'm not sure if that is or isn't true. I'm not an artist that works with acrylics or different paints and stuff like that. I do a bit of digital art and some drawing and stuff like that, but I'm not the paint master, I will admit. And with it in mind that with staking coming to Ethereum, proof of stake should be 99.95% more efficient than what's already going on. And if that's the case, then instead of it being 2 times as bad as the footprint for a tin of paint, it would be multiple times better. And all this would have happened within 72 months of the creation of NFTs. You can't say that about the paint industry. You can't really say that about many, if any, industries. Unfortunately, that's actually one of the things that is very good about anything that is software or code related. When we think back to my personal experience with compressed air equipment, the efficiencies achieved are normally through some sort of manufacturing or design feature, be it the way that the air end is designed in order to get the maximum output, the minimum amount of resistance. We can design and engineer more efficient products, but there is a limit to the speed and results at which we can achieve. So those mechanical engineering things that I've just talked about might only add an extra 3 to 5% efficiency, and they do them in 5 or 6 different places every time that they bring out a new generation of model, say. It's a lot easier to get a 99.95% efficiency increase on something that is code-based than something that has real physical limitations. I just thought it was important to highlight this aspect as another reason why this industry is so valuable. And look, I understand that there's a moral stigma of harming the environment. It's a powerful and driving factor when making commercial decisions about a company, brand, or organisation. But getting up in arms about the impact of NFTs in this early stage is like getting angry that the car was as inefficient as it was when it was created.
I'm sure you're aware of the Great London Horse Manure Crisis of 1894.
I'm afraid I'm not.
In the 1890s, the Industrial Revolution had people flocking to the city, and more people equals more horses, and more horses equals more manure. And it was predicted that by the middle of the next century, there would be 9 feet of manure covering the streets. But what no one saw coming was a new technology that would completely obliterate those concerns. The car. Overnight, the manure problem vanished.
Regardless of the challenges NFTs will face, it's clear whatever the consumption is, incremental improvement will provide increased efficiency and a reduced effect on the environment. It seems that there are 3 main routes to trying to achieve this. 1. Use a different blockchain. Look, if Ethereum uses too much CO2 or electricity per transaction, that's fine. There are other blockchains, soon to be ADA, Tezos I believe, that you can mint NFTs on that have significantly reduced environmental impact. 2. As I said earlier, once Ethereum moves to proof of stake, the efficiency level will increase over tenfold. Thirdly is to embed and bind these into systems whereby they can only use a renewable or net neutral supply to prevent additional carbon wastage from being accrued.